which gives me 100 newtons downwards. Now the direction is very important. All right, so that's my net force. Now how do I use that to solve for the air resistance force? Now I know the temptation again is to write 100 up. And that would be true if the net force was 0. And this was the force of gravity. But it's not. So that doesn't quite work. So I have to set up the full equation. 100 newtons down, net force equals sum of all forces. So it's mg plus air resistance. mg is 2, and we're going to call it times 10. Or sorry, 50 times 10. Well, meters per second squared. Plus air. So this is 500. I subtract 500, and I get minus 400 newtons down equals my air resistance force. Okay, I may have skipped a step on you there. So I subtract 50 times 7 is 500. From that, 100 minus 500, and I did everything in the downwards direction here. Always choose a direction right off the bat. I could have chosen up, which would have made this a negative 100 up, and a negative 500 up, and then I would have had add 500. So 500 plus a negative 100 would have given me 400 up. But I decided to do it in the downwards direction, so I have 100 down equals 500 down plus air. I subtract out 500, I get negative 400 down. Or you could have wrote plus 400 up. And to me, these two things mean the exact same thing. Or you may want to check with your teacher to make sure that they consider those the same thing as well. Probably will. Now, why is sign and direction so important? Well, there's a big difference between having $1,000 in your savings account and having a $1,000 bill in your credit card account. They're the same number, but with a very different sign. All right, so I think that's all for this lecture. So to wrap up, we've seen from Newton's law that net force equals mass times net acceleration, and then net force equals the sum of all forces. Gravity force is the downwards force from gravity. Acceleration depends on your mass and force, but for a given force, it depends on your mass. So a bigger mass with the same force will give you a small acceleration, and a small mass will give you a big acceleration. In free fall, you have no weight because there's nothing pushing you up. The weight is basically your normal force. You do still have gravity force. And not free fall, the net acceleration depends upon your net force. So the net force equals ma, your acceleration is the net force divided by m. I think that concludes for today's lecture. By the way, this is is this the first from chapter 3? This is to be one of those where we split it into 2 for a week. There'll be a lot of weeks where we do that. This will be one of those.